Hi, Math 30-2s. What we're going to take a look at today is just problem solving with perms and coms. So you won't know right away whether it's a permutation or combination because now they kind of combine everything together, and you're going to have to determine, does order matter, does it not matter, okay? Do I want to use permutations? Do I want to use the fundamental counting principle? Okay, so the decisions become a little trickier. But the nice thing that they've done for us is at the beginning of this lesson is they've kind of written down all the key things that we need to remember moving forward here. So fundamental counting principle, okay, what factorial notation looks like, the formula for permutations, okay, with repetitions we divide by what's repeating in the denominator, okay, and then the formula and the way we notate combinations, okay. So again, just like I had mentioned at the beginning of lessons, it is essential to determine whether order is important or not, okay. That'll be the key thing that we want to focus on as we take a look at today's lesson. So first question says, how many arrangements of the word poppies can be made under each of the following conditions? So without restrictions. So again, what I take a look at when I do a question like this, okay, is I want to know how many things I want to order. So that's 1, 2, 3, 4, 5, 6, 7. There are 7 elements or 7 things that I need to arrange. So the way we arrange 7 things is just 7 factorial. But what I also notice is that there are 1, 2, 3 letter P's. So I have to divide by what's repeating, and that's 3 letter P's. So there's your calculation. So 7 factorial, okay, and you divide by 3 factorial, okay, that will be a total of 840. Okay, in B, it says, if each arrangement begins with a letter P. So again, if you take a look at that, like I mentioned at the beginning, there are 7 things. So 1, 2, 3, 4, 5, 6, 7. 7 elements or letters in this case that I want to arrange, but it says the first has to be a P. So I make that happen. Now that's going to happen, so it's kind of like it gets taken out of the calculation in the sense that I just cross off 1 P because it's going to be first. So what I have now are 6 remaining things to be ordered. So there would be 6 remaining things to be ordered because I've taken out 1 P, and of those 6 remaining things, there are now 2 repeating P's. So you just go 6 factorial, okay, divide by the 2, or 2 factorial, okay, and that gives you a total of 360. Okay, see, very similar in the next one. So this time the first 2 letters are going to be P, so P and P, okay? So that's kind of taken out of the calculation, isn't it? Because they have to be P and P. So that means there are now 5 remaining things to be ordered. Okay, now there will be no repetitions now because there were 3 P's, 2 of them are now have to be first. So of the 5 remaining letters, they're all different. So 5 factorial, which we know is 120. Okay, next one, if all the P's are to be together. So again, remember when things are together, we kind of stick them together with glue, pretend that they are stuck together. So the 3 P's are kind of like one letter. So I'm really ordering 3 P's, an O, and I, and E, okay, and an S. So if you take a look at that, because all the P's are stuck together, there's just 5 things there, right? So that's just 5 factorial, 120. Okay, E is a little trickier, okay? So it says if the first letter is a P, so you make the first letter a P, okay? And the next one is not a P. So the next one can't be a P. So if you take out, I'll just write it out here on the side, P-O-P-P-I-E-S. So if I make the first one a P and the next one cannot be a P, that means there are 1, 2, 3, 4 options, okay, for the next one not to be a P. So there's a 4 there. And then following that, there would still be 1, 2, 3, 4, 5 things to order, okay? Now, of these 5 things here, okay, I can order those 5 factorial ways, but in there will be 2 P's that are repeating. Okay, so your calculation will be 4 times 5 factorial over 2 factorial. Okay, so 5 factorial, 2 factorial, we know that is going to be, okay, this times 4, so 240, okay, is the final calculation there. Okay, next page. A class consists of 5 girls and 7 boys. A committee is to be formed consisting of 2 girls and 3 boys. Determine the number of ways a teacher can choose the committee if, okay. Now notice there are again no basically titles or positions on this committee. You just want to be on the committee or not on the committee. So this is going to be a question that deals with combinations, okay? So no further restrictions, okay? No further restrictions. So let's deal with the girls first. So there are 5 girls, and I need to choose 2 of them, okay? So there is the calculation for the girls. The boys, okay, how many boys? There are 7 boys, and I need to choose 3 of them, okay? So that is 10. That's what 5 choose 2 is, okay? 7 choose 3 is 35. Okay, so 10 times 35, okay, that is 350, okay, as a total calculation there. Now, in B, Johnny, the principal's son, has to be on the committee. So just like in the last question with the P's, okay, where you make the P first, okay, you make that happen. So Johnny, the principal's son, is going to be on the committee. Now, that does not change the girls, okay? 5 choose 2 is still going to be the combination for the girls. What Johnny, the principal's son, being forced or being placed on the committee does is it changes the total number of boys from 7 down to 6, and now I only have to choose 2 more boys, okay? So we know 5 choose 2 from the part A was 10. 6 choose 2 now, okay, is 15. Okay, so that is just an answer or a total of 150, okay, or 150 ways. Okay. So what I'm going to do in C is it says the twins, Peter and Paul, cannot be both on the committee. Okay, so what I'm going to do in this one is I'm actually going to use the complements. Now, do you remember what the complement is? Is you take all basically ways that something can happen and subtract what you do not want. So what I'm going to do in this question is going to be like no restrictions. Okay, so that's everything, right? So no restrictions. Okay, and then I'm going to minus the opposite of what I'm looking for, which is what? They're saying Peter and Paul cannot be both on the committee, which is Peter and Paul both on the committee. Okay, and that will give me the same calculation, okay? Less steps. So no restrictions, we know that. That's basically the calculation I did in A, isn't it? No restrictions at all. So that's going to be 350. Okay, so that's pretty easy. I just steal the answer from A. Now, Peter and Paul both being on the committee, again, it does not change the way that I select the girls, right? It's 5 choose 2. What it does is affects the calculation of the boys. There were 7 boys. I put Peter and Paul both on the committee. That means there's only 5 boys left, and I only have to choose 1 more because there has to be a total of 3 boys. Peter and Paul are both on there, so only 1 more boy to choose. So this becomes 350 minus, okay, so the 5 choose 2, 6 choose 1, so that's 50, okay? So the final calculation here is simply just 300, okay? Last question here. So it says use the following information, okay, to answer the next class example. David, Stephen, and Helen were trying to answer the following homework question. Okay, the students in the school band have practiced 5 popular and 6 classical music compositions. For the school concert, they will choose a program consisting of 3 popular and 2 classical music compositions. If the order of the compositions matters, okay, so right there you know that you're most likely dealing with a permutation. Okay, determine the number of different programs which can be presented, right? So again, you now know moving forward that if you're dealing with the way things happen, so, you know, songs in a program, music songs on a list on your iPod, on your phone, okay, it's going to be a permutation because if I have 2 songs and I change the order that those songs are played, okay, it's a different playlist now. So that is a permutation as well. So it says the students' answers were shown below. David said the calculation would simply be 11p5. Stephen said that it would be 5p3 times 6p2, and then Helen said 5 choose 3 times 6 choose 2. Each student was convinced that their answer was correct and asked their teacher to check their work. The teacher asked the students to write their answers on the board and asked the class to discuss the merits of each answer. So part A says, if possible, discuss the merits of each answer with the other students and indicate the errors in their thinking. Okay, so very quickly I'll tell you that all 3 students are actually incorrect, okay, in the way that they went about trying to solve this problem. There are things that I like about each calculation, okay, and we'll discuss those, but I'll tell you what is actually wrong with each calculation. So David, it's pretty easy to see what's wrong with David's right away, isn't it, okay? He simply just goes 11p5. So what he does is he kind of puts the 5 popular and 6 classical in a bin, okay, just chucks them in one bin. There's 11 songs and he pulls out 5. So the issue with that is that in his calculation, there's no way of ensuring that he will get 3 popular and 2 classical, okay? He could end up pulling all popular or all classical because he groups them together when he tries to do the calculation, okay? And that is incorrect. With Stephen, okay, the problem with Stephen is that Stephen assumes that the popular compositions must be played consecutively and then the classical compositions must be played consecutively. So what that means is that, see, he chooses the 5p3, so he does the popular first, okay, and then he calculates choosing the classical songs, okay? So he does the popular and then the classical. That's the multiplication in there. There's nothing saying that I have to have the popular and then the classical, okay? I could have popular, popular, classical, popular again, okay? So they can be mixed, okay, in the way that they're in the program. He's selecting the popular first and then the classical, okay? That's not what we want to do. Now, Helen, again, you'll probably see what's wrong with hers right away. Okay, she is doing something similar to Stephen, okay, but she also says that it's a combination, which is incorrect because they clearly state in the question that order matters, so it needs to be a permutation, okay? So Helen does determine the number of selections possible, but does not arrange them in order. So all 3 of those calculations are somewhat incorrect. They did things well. A couple things in each calculation are done well, but there are errors that basically make them all incorrect. So in B, what we're going to take a look at is how we do this properly. So this is the teacher indicated all 3 students had an incorrect answer. Determine the correct solution. So what we have to do is the following, okay? I need to select the right number of popular, the right number of classical, and then once I've done that, then I order them. Okay, so here's the way it goes. The first thing I would do is select the popular songs. So if I'm going to select the popular songs, I'm going to go 5, choose 3. Now you're going to go, why are you choosing them and not using P permutation? Because order matters. I will order them after I've selected the songs. Okay, so 5, choose 3. Okay, this is just the selecting. Okay, the popular songs. That's all I'm doing. I'm not ordering them yet. I'm just selecting them, right? It's like being on a committee or not being on a committee. I'm just choosing them right now, okay? Then I must do what? I must select the classical songs. So 6 classical songs, I have to choose 2 of them, okay? This is selecting, okay, the classical songs. So at this point, I would now have the songs I'm going to use, okay, at the band concert. Okay, I know which ones I'm going to use. Now, what do I have to do? Now I have to order them, okay? So I have 3 popular, 2 classical, that's 5 things. So how do you order 5 things? 5 factorial, okay? So this is the arranging, okay? So the permutation part of the compositions, okay? That's what this is. So when, compositions, I have to spell it properly, but when you have a question like this where you're selecting from one group or one bin and also selecting from another group or another bin and then you want to order, this is the way we deal with those questions. We choose, so combinations the first group, we choose combinations the second group, then I take the total number of elements or things that I have and then I order them. So all that's left to do now is do this on my calculator. So we're going to go 5, choose 3. Okay, times 6, choose 2, okay, times 5 factorial, 120, okay, and you will get that there are 18,000, okay, different programs that are possible. All right, so that is the end of this chapter, okay, problem solving with permutations, combinations. I will have a test date for you guys in the next day or so. So just be looking for that, but practice this today, try the practice test, and then we just have 1 chapter left, okay, so that will be done in the next 2 to 2.5 weeks, and then that's it for Math 30-2. So any questions, obviously, again, with either these lessons that I'm putting up or with what's happening moving forward, just email me and I'll get back to you as soon as I can. Thanks, guys.